And of course, if you make a 2D to 3D with existing materials, leave the engineers at it, they'll come up with newer and newer materials. And this is the resistive RAM technology that's going to take over the longer term. So this is the progression that you see this decade and into next decade to handle that 40 zettabytes of data. So let's go back to 2D NAND a little bit more. And you see these rocket-like structures? This is how the actual flash device looks. And each one of them going one generation after the other. These are, you talk about microscopically, nanoscopically tall structures. And the reason these become so difficult is, and this is what I was talking about, our electrons misbehaving. You take the same flash device, a memory device, and you read and write, and you read and you write, you erase, you read, you write, you erase, you read, write. You do this a few thousand times. Those electrons start to get a little tired, and the distribution start to expand. The same bit when you switch from yes, 0 to 1, how am I going to scale this technology further and further when there are not enough electrons? We are talking 20 electrons. I mean, we are not talking of large quantities of charge that we used to do once upon a time. 20 electrons, just the number scares me. And this is one of the biggest problems we handle, is as you scale, the number of electrons goes down. Then comes this other problem. Everybody wants more bits on the same chip. So when we started making NAND devices, we used to make megabyte chips. It became 64 megabyte. These days, a typical chip is 128 gigabit chips. 128 gigabit in a single little piece of silicon. That's 128 trillion bits on that one device. So what happens is this. To make one bit, you need a 0 state and a 1 state. If you can put 2 bits in the cell, you need 4 states. 0, 0, 0, 1, 1, 0, 1, 1. 4 bits. Then of course we get a little bit more greedy. We want to have 3 bits in a cell. So now we have 8. Now what happens when you put 8 bits in a cell and you really have a thin device? You start to now overlap. All of these distributions overlap. You don't quite know if I'm reading the right one. So now you start to have probabilistic effects. Maybe it is a 1, maybe it is not quite a 1. And then the last worry with this is lithography that I was just talking about. How am I going to print smaller and smaller devices when the wavelength of light is a fixed thing and can't go much lower? The machines to print these have become a single machine, a lithography tool, costs $75 million. A single lithography tool today costs $75 million. My friends from Applied Materials probably are sitting here and they're wondering why they are not in the litho business. That's where the biggest markets are, $75 million per tool. And these tools are getting more and more expensive. And one bit goes next to the next bit, and they're putting right next to each other, one starts talking to the next. So these are the different ways, as I started out saying, electrons are misbehaving. Electrons and atoms don't quite behave the way we ask them to. So these interference causes a lot of problems for us. So that's why I was talking about the real estate prices and why we need to go 3D. Some bright guy from our partnership between SanDisk and Toshiba figured out, if I can have these devices that are horizontal, if I flip them on the side and build them vertical, oh my God, I can build multiple bits on that same spot, and I can have enough housings for those electrons. Those electrons can live, instead of big ranch houses, they can live in apartment houses, and these apartments can be built one on top of the other, and we now start to build 32 layers, 64 layers. These are truly 64-layer tall apartments. one above the other. And that 3D NAND is going to revolutionize flash. You heard it here first. This revolution on going from 2D to 3D is going to transform the storage business. The storage business is going to has not seen anything like it in the past, how quickly we can account for those 40 zettabytes. And that's all going to be based on this 3D NAND. And this 3D NAND is built on the same fabs, using the same machines. No longer is it limited by lithography, no longer is it limited by number of electrons, no longer limited by one bit sitting next to each other. Everything we talked about, this solves it. They're building large number of these apartments in the Bay Area these days, Bay Area in Silicon Valley. The real estate prices had gotten so much, where they have originally 1 acre homes where 4 people lived. Now, in 1 acre, they are trying to put 200 people with these high density housings. Exactly what we are doing in flash. Very high number of electrons in very large number of apartments built one above the other. And this 3D is going to be the basis on which the flash economy is going to be built. And you're going to see within the next 2 years, most of your cell phones, as they are growing up in capacity, as they are going in density, the number of megapixels grows, the number of megabytes of memory, that gigabytes that you need are growing, are all going to be done by these 3D devices. So the other big deal about these 3D devices is because they are built vertically, none of these proximity things, one next to the other, they don't affect it. They are very, very isolated, strong, robust devices. A transformation that is happening in the flash industry is this movement away from retail flash into more and more enterprise-oriented flash. Enterprise meaning in data centers, where these big rotating disks are now holding all your memory, which consumes a lot of power. You now move to more and more solid-state data centers. And when these solid-state data centers come around, these vertical memories, these 3D structures, are ideally suited for them. As the retail market matures, the big enterprise market grows, the enterprise market will be dominated by these 3D memories. So even given that, technology never stops. Technology is always trying to find, okay, if I can do that much density, can I do one more? And the next comes, what if we didn't have to have electrons? We never had to go store these number of electrons that are going down all the time. We're talking about zettabytes, which is 10 to the 18 bits. The only number I used to know bigger than that is the Avogadro's numbers. I don't know if any of you remember your high school physics Avogadro's number. 6.023 times 10 to the 23. There is 10 to the 23 atoms somewhere. We can go play with them. Instead of doing electrons, let's go to atoms. Now you can do completely electron-free memories. And those are these resistive RAMs. These resistive RAMs are coming right behind these 3D electron-based apartment structures. And we are going to move into this technology later part of this decade. So what this says is, over the long term, when we want these 40 zettabytes of memory to be built, there is not going to be a limitation from technology. The limitation only is the imagination of the people here who can use them in newer and newer applications. When this transformation from retail memory is moving on into enterprise storage in data centers, in cloud, and putting everything in the cloud, we're going to need a lot more memory, lot more ways of using these memories. Technology is standing right behind. Newer methodologies, newer ways of making it are coming right behind that can supply the memories for every one of these applications. So, to finish up the talk, The key technology takeaways: NAND is scaling. From our current 2D technologies, we can go from existing 19 nanometer to 16 nanometer to 14 nanometer. We will continue to do it. Just in case that is not enough, the 3D memories are right there. In the next 2 years, you're going to see in enterprise applications and in retail applications, you're going to see a lot of 3D memories. You're going to be in high volume production as soon as the end of next year. So it's not something in the future. It is coming off of the existing factories. And right after that, moving from electrons to atoms, trying to figure out how we can make resistive RAM to work. And so all of these technologies, 2D, 3D, resistive RAM, BICs, they're all going to coexist, supplying the solutions that you need for you to store your 40 zettabytes of memory that you'll be producing. Thank you.